Hello, class. We're about to start lesson 8 from chapter 7, which is called Combined Figures. Now, it says we're on page 406 in your textbook. It says breaking combined figures into parts. A combined figure puts together geometric figures to form a new shape. To find the perimeter of a combined figure, simply add the lengths of the sides. You may need to solve for one or more missing lengths. Okay, example 1. A family room has the dimensions shown in the diagram. All dimensions are in feet. What is the perimeter of the room? Now, if you notice here, some of this is a little grayed out, but this is an 8 over here. This is a Y, 18, X, 10, and 4. Now, if we look here, first of all, we know perimeter is the distance around the figure. So we know we can add 18, we would add this 8, this 4, this 10, but we need to find out what X and Y is equal to. Now to find out what X and Y is equal to, let's look at X. X is this side here with 8 added on to this side of 4. So X is 8 plus 4, which is 12. So that will be 12. And then now we need to find out what Y is. If you look here at 18, 18 is this 10 plus this Y. So that means Y must be 8. So then we add all of those sides together, and that gives us the perimeter of 60 feet. Now we come here with example 2. It says to find the area or volume of a combined figure, break the figure into parts, then apply the correct formula to each part. What is the area of the figure in square centimeters? Now, they want us to do the area. Now, the area, we have to look at what two figures that this might form, which they have here. If you drew this imaginary dotted line, you have a rectangle over a trapezoid. So we'll do the area of a rectangle, which is length times width, which gave us 10. So we have 5 times 2 is 10. And then the area of a trapezoid. Now this trapezoid here, we have half of the height. The height is 3, because this is the trapezoid. And then we have the base, the shorter base, which is 5, and the larger base, which is 7. So after we multiply all this, this gives us 18. So we would add these two together, and that gives us the area. Now we come here to this volume figure. It says find the volume of the container shown below. Now with this volume, you have a cylinder and a cone. So the cylinder volume is pi radius squared times height. So we know pi is approximately 3.14. The radius here is given to us as 1. And then the height, we will only go up to 2. So the height is 2, so that gives us 6.28 cubic meters. Now we go to the volume of the cone. The cone is 1/3 of pi, 3.14. The radius, the cone, the circular bottom of the cone is the same as the circular bottom of the cylinder. So its radius is the same, which is 1. And then the height, we're shown here the height of the cone, which is 1.5. So that's 1.57. So we add these two together, and it gives us the cubic meters of 7.85. Now we're going to apply this. Now I don't know why some of my figures came out so light, but we're going to go through these. Okay, first of all, number 1, and you see how it's separated. We have a trapezoid, and we also have a rectangle. Now the split actually should have went here, but for some reason they moved it over here. I don't know why, but this is where the split should have went. So we have the perimeter. So let's do the perimeter first. We have 30, well, let me put P is equal to, we have 30 plus the side that has 25 plus the other side that has 25 plus 15 plus 20. The only side we're missing is this side here. So we would need to add this 20 plus this 15, and that would take care of this whole side. So that would give us a total of 35. So now we add all of these together. 30 and 25 is 55. 55 plus 25 is 80. Plus 15 is 95. Plus 20 is 115. Plus 35 is 150. So this is 150. That's the perimeter. Now we have to do the area of two separate figures. First, we'll do the area of a rectangle. And then we would do the area of a trapezoid. So the area of a rectangle we know is length times width. The area of a trapezoid is 1/2 times the height times the smaller base plus the bigger base. Okay, so now the length times the width. If we take this figure here and we draw this line here, we know that this side is 35. So it'd be 35 times 20. 35 times 20 is 700. That would be the area of this rectangle. Now we do the trapezoid. Now here's the trick with the trapezoid. First of all, we add half, and then the height, we know this height of the trapezoid is going to be 20. The height is 20. Now the smaller base. Now we look here. First of all, this line should have been drawn here. Now we know from here to here is 20. So that means for the top of the trapezoid, that should just be 10, because this whole side here is 30. So from here to here should be 10. That'll be the lower base. And then the larger base from here to here is 25. So now that would give us 1/2 times 20 times 10 plus 25 is 35. Now when we multiply this together, this will give us 350. So now we add up this area. So this area will be 700 plus 350, which is 1,050. That would be the area of the rectangle plus the trapezoid. Okay, the next figure, problem number 2. Now, if you notice here, okay, first of all, this side is 12, and this side here is 10. So you may need to write that in there. Okay, so from here to here is 12, from here to here is 10. We know with an imaginary line here that this would be a rectangle and half of a circle. So we would do the perimeter. Well, let's do the perimeter first. The perimeter will have us at 12, 16, and then we will have another 12. Now, the problem is this half a circle. Now, we know that the perimeter of a circle has a special name called the circumference. The circumference of a circle is, let me just do this, circumference. We will have pi times diameter. But remember, it's half of a circle. So what we will have to do is do half of the pi times diameter. So then we have half of 3.14 times the diameter. The diameter would be this value here, which is 10. So now up here we will have, what's that, 24 and 16, that'll be 40. And then here we have, let's see, 15.7? Yeah, 15.7. So now we will add these two for the perimeter. So our perimeter will equal to 40 plus 15.7, which is 55.7. So that will be our perimeter for that rectangle plus the half of the circle. All right, now what we would do, so now we do the area. So we'll do the area of the rectangle first. And we know the area of a rectangle is length times width. And we had a length of 12 and a width of 10. So that would give us, oh, you know what? I made a little error earlier, but I'm going to correct it here. Okay, so this would give us 120. But up here, I don't know why I got 16. This should be 10, not 16. Because remember, the perimeter is the distance around. So this is supposed to be 12, 10, and 12. So I made a mistake here. So that'll be 10. So this will give us 34. So it should be 34 plus 15.7, which will give us 49.7. All right. So with that being said, again, that should be 49.7. I made an error in putting 16 instead of 10. So just make sure you correct that. Okay, so now we did the area of the rectangle. Now we're going to do the area half of a circle. Now we know the area is pi radius squared. But remember, this is half a circle, so we'll do half of pi radius squared. So this would be 1/2, pi will be 3.14, and then the radius, now remember, the radius is half the diameter. The diameter is 10, so half of that would be 5, and that's squared. So now we have 1/2 times 3.14 times 25. Now we could put this in our calculator. So we would have, now your calculator, you know, you would do the fraction bar, but what I'm going to do is I'm going to put in 0.5, and that'll be my half, and then 3.14. Put these parentheses here, and then 25, and that would give me 39.25. Now to do the area here, we would add both of these together. 120 plus 39.25, which will give us 159.25. That would be the area for that problem. Now, they didn't ask us to round, so it'd be 159.25. Okay, now, we go to the third figure. The third figure, as you see here, it looks as though we would have a trapezoid, two trapezoids actually, when we go to figure out our area. So let's go here to problem number 3. Now we're going to do the perimeter. So I'm going to start at the bottom and work my way around. So at the bottom we have 9 plus 3. We have 15 plus 12 plus 6 plus 17 plus 10. Now it gave us all of the sides. It's not a missing side on this figure here. So we would add all of them together. 9 plus 3 is 12, plus 15 is 27, plus 12 is 39, plus 6 is 45, plus 17 is 62, plus 10 is 72. So it's 72. This is your perimeter. So P is equal to 72. Okay, now we want to do the area. So we will have two areas. It'll be two trapezoids. Now, the area of a trapezoid is half the height times the small base plus the larger base. And the formulas are the same. So let's go with the first trapezoid. This first trapezoid goes to here. It's here and all of this up here. So with the smaller side, if you notice here, this is 12 plus 17, which is 29, which covers the whole figure. Okay, now from here to here, well, let's take a look at this. Okay, and re-looking at this trapezoid, this will be the end of the first trapezoid, and then this would just be the second trapezoid. So let's just take this value here. So we have half of the height. If you notice, with this trapezoid here, the height is just 6. So the height is 6. And then we will have our smaller base, which would be down here, which would be 9, plus our larger base, which would be here, which would be 17. So this would be half of 6 times, this would be 26. So this would give us 78. Now for the second one, we have our height here. Our height would be this 6 plus this 6, which would be 12. And then we have the first base, the smallest base, which would be 3, plus the larger base, which would be 12. Okay, so it'll be half of 12 times 15. So this right here would end up being 90. So now to add up this area, we'll have 78 plus 90, which will give us 168. So now, that took care of those first 3 problems. Now we go down here where it says find the volume. Now with these volume problems, we know we're going to use the volume formulas, which isn't that bad. All right, so the first volume for problem number 4. Now if you notice here, it looks as though that we have 2 rectangular prisms together. So the volume of a rectangular prism, we have to go back and get that formula. Now the volume of a rectangular prism is length times width times height. Okay, so we're going to do that twice, because we're trying to find the volume of the larger one and the smaller one. So we have the volume of length times width times height. Okay, so now if you look here, I think the smaller one would be easier to do. So we'll do this here. So that'd be 4, 3, and 5. 4, 3, and 5. Okay, now we'll take this larger one. Now if you look here on this side, 2 plus 3 is 5. But if you look here, this looks like a cube, but we can still use the rectangular prism. So it'll be 5 times 5 times 5. Because it'll be 5, the length, width, and then the height also would be 5. So this would be 125. This here would be 60. So the volume would be 125 plus 60, which is 185 for problem number 4. All right, problem number 5. And remember, we have cubic units here. Okay, now, the next problem here, now remember I told you you had to get the formula for the rectangular prism. So your volume formulas are actually on page 398 and 400. So just to let you know, it's on 398 and 400 if you need those volume formulas. So right there, with this figure here, we have a pyramid, and it looks like it's on top of a rectangular prism. So the volume of a pyramid would be 1/3 your your base times the height. Yeah, 1/3 base times the height, which is basically 1/3 your base squared times the height, because your base is basically the same thing twice. So it's your base squared times the height. All right, now the next thing, the volume of a rectangular prism, we know is length times width times height. So you have 1/3, the base here of this pyramid, you notice it'll be 7. It's the same length as these 7s here. So it'll be 7 squared, and then the height is 8. And then here the length is 7, the width is 7, and the height is 3. So this will be 1/2 times 49 times 8. And then this will be, 147 when we multiply this out. So now we'll multiply this out. See, this will be 196. So now we have 100, the volume is the 196 plus the 147. You add these together, you add 343. All right. Now, the last one on here is, let me take a look here. Okay, so we're dealing with number 6. We have the cylinder and we have a rectangular prism for number 6. So the formula for the cylinder, again, if you don't have it written down, you look back on page 398, and the volume of a cylinder is pi radius squared times the height. And then we have a rectangular prism, which is volume is equal to length times width times height. Okay, so now the volume of the cylinder, we have pi, which we'll put as 3.14. The radius, we see here is 10, but we take half of that. That's the diameter is 10, so the radius is 5, and that's squared. And then the height, we see here off to the side is 2. Now for the volume, we have length times width times height. So that'll be 11 times 11 times 2. All right, now, so we had 3.14 times 50. 3.14 times 50. And then we will have 121 times 2. So 3.14 times 50 will give us, let's see, 157, I do believe. Yes, it'll be 157. And then here we will have 121 times 2, which would be 242. So now we add them. So the volume would be 157 plus 242, which would give us, let me see, 9, looks like 399 for problem number 6. Okay, now we go down here to problem 7 and 8. All right, problem number 7. It says choose the one best answer to each question. A slab of concrete will have 4 concrete blocks in each corner as shown in the drawing below. All right. It says in each corner, if each corner block has the same dimensions, what is the volume of the structure in cubic feet? So basically what we would have here is, we would have, this is a composite figure. So by we having a composite figure, it actually looks like it's about 5 figures on here. So we have the volume, and all of them are rectangular prisms. So we have the volume of 5 times the length times the width. No, I'm sorry, 4 times the length times the width times the height. And the reason why it's 4 is because they said these 4 have the same measurements. So whatever you get for one, you'll multiply by 4, and that will give you all 4 of them. And then the volume of the larger rectangular prism will be length times width times height. So now we have 4, and then we have 3 times 3 times 2, 3 times 3 times 2. And when we multiply this out, 4 times 3 is 12, times 3 is 36, times 2 is 72. So that equals 72. That's the volume of all 4 of those together. Now here for the larger, we will add 3 times 8 times 12. All right, so what we will have here is 96 times 3, 18. So it'd be 288. All right, so we would add these together. We have 72 plus 288. See, 0 carry our 1, 6 carry our 1. So it'd be 360, which is D. So that is the volume of this whole figure for problem number 7. And then that would be actually cubic feet. All right. So now we go to problem number 8, which is our last problem. It says a candy package is in the shape of a cylinder with a cone on each end. Okay, if the radius of the cylinder is 2 inches and the cones are identical, what is the capacity of the container to the nearest cubic inch? So what we would need to do here, it looks as though this is still dealing with volume. So, but I believe, if I'm not mistaken, this is dealing with the volume on page, let me see, they have the volume of a cone on page 400. So I'm going to write the volume of a cone, which is 1/3 pi radius squared h. That is the formula for a cone. And then we have to do the volume of a cylinder. And we know the volume of a cylinder is pi radius squared height. Now remember, we have 2 cones here. So we know we're going to take this and multiply by 2 to get the volume for each one. So we have the volume is equal to, it'll be 1/3 times pi, which is 3.14. Now the radius, they tell us that the radius is 2. So that'll be 2 squared. And then the height, if you look here at the height of the cone, it does not, okay, so if the height, okay, from here to here with the cylinder is only 8 inches. And if you notice, from one end to the next is 16. So that means that both of these will have to have a height of 4. Because total, these will be 8, because 8 and 8 makes 16. So the height here would be 4. So we will put 4 and then times 2, because we're doing it by 2 of them. So now when we put this in our calculator, let me just put this in a calculator real quick. So we will have, now I have to do this a little different because I'm using a different calculator. But you all could put this in your calculator as a fraction. So you have 1/3 times 3.14. Now 2 squared we know is 4, so we could just put 4. And then times another 4. And then times 2. And that gives us approximately, say, 33.49. Okay, that took care of the volume of the cones. Now we're going to go with the volume of the cylinder. So we will have 3.14. The radius will be the same for the cylinder, which would be 2 squared. And then the height of the cylinder is right here, which would be 8 inches. So we will add 3.14 times 4 times 8. All right, so we could put this in our calculator. So we add 3.14 times 4 times 8. And that gives 100.48. All right, so now we're going to add both of these together to find out what our final answer is. So we will have 33.49 plus 100.48. Now, when we add these together, it'll give us 133.97, which is approximately 134. Now, when we get to the 134, we will have, that'll be C. So your answer here would be C. And remember, these were supposed to be cubic inches. So your answer is C, and we are done with lesson 8 from chapter 7. I will upload this to YouTube, and have a wonderful day.